Like many others on the surface of the Earth, the Alps are amazing mountains of more than 3,000 meters in height. They carry on their surface scraps of sedimentary rocks which were accumulated at the bottom of the sea. The proof is that these rocks teem with marine fossils. How is it possible? The explanation is in Alfred Wegener's brilliant ideas suggested in 1912. These ideas began by arousing a real scientific argument until 1950, when they were universally accepted. Here, in a few words, is an explanation of what takes place under our feet. The Earth's crust on which we live is cool and of weak density, 6 or 2.7. It floats on a coat strongly warmed by the internal radioactivity of the globe, roughly 1800 degrees centigrade, and of clearly higher density, between 3 and 5. Below the coat, at around 3,000 meters of depth, the temperature is so high, between 3 and 4,000 degrees centigrade, that the core becomes practically liquid. The difference of temperature and plasticity leads to gigantic internal bubbling, the visible consequences of which are the formation of the oceans and mountains. The Earth's crust plasticity is very low, but not absent. It can move and wrinkle at a speed of 1 to 1.5 centimeters a year without breaking itself, exceptionally 5 centimeters in case of surge and earthquake. The plasticity of the coat is much bigger. It can move from 10 to 15 centimeters a year. Attention! This drawing is very simplified, because there is, of course, numerous secondary and local bubbling which is not represented. On the surface, these mass movements with an enormous scale pull the crust which floats on its back. Coat layers wrinkle, overlapping some on the others and forming mountains, which are slowly affected by rains and frost. Under their weight the coat sinks. When he contemplates a landscape of mountain, the pleasure and the art of the geologist is to reconstitute the very slow movement of the mineral masses which are wrinkled, mixed, and broken by floating in the burbling depths of the globe. Here is, for example, what famous Professor Hele Badou saw and drew by observing the tablecloth of Morcle in Swiss pre-Alps. The plasticity of rocks is surprising, but we must remember that this mineral architecture was organized very, very slowly, during 10 or 20 million years, in a variable speed of about 1 centimeter a year, and at the same time there were some earthquakes which were the consequence of a sudden break of constraint. The Alps are the result of the gigantic collision of Italy, coming from the south to meet the European plate. Throughout the endless geological times, the continental plates never stop moving, tearing and colliding. About 160 million years ago, for example, the African plate is slowly taken away from Europe by sliding southward, creating the immense Sea of Tethys. About 60 million years ago, the African plate raised northward, pushing aside the Spanish and Italian plates which collided with Europe. It is necessary to reconstitute this collision in section. Everything begins 45 million years ago and still probably continues, as the recent terrible earthquakes in central Italy tend to show. Future pre-Alps, here represented in black, are made by some marine sediments deposited at the bottom of the Alpine Sea in the north of Tethys. These sediments are transported on about 140 kilometers towards the northwest, because they are on granitic masses floating on the coat. Alternately, the granitic summits of the Alps appear. They are stripped by the erosion, producing stiff morass which accumulates in their feet. In current alpine fronts, native sediments and molasse are also repelled on about 40 kilometers before wrinkling to form dura. Try to imagine a tiny animal with a life expectancy limited to a fraction of a second. Here it is observing the waves which fall on a beach. Of course it considers them motionless. On the condition of being rather ingenious, it will possibly invent ropes and ice axes to explore them. Maybe it will enjoy making skids on the backs of these waves, but it will not realize that they move inexorably. By contemplating the mountains which surround us, we make exactly the same error, because mountains are in movement, but too slow, so that we, poor animals, can perceive it. Of course, in this video, our animations are a little bit simplified. For example, we did not evoke the numerous conflicting hypotheses which tend to explain the formation of granites, resulting in a rebooking of sedimentary rocks. We do prefer to illustrate the following image. Continents are like pieces of paper floating on some boiling water in the inside of the globe.